Great. I think we can slowly start our session. I see Yulan has also joined us. Yulan, just quick to check with you whether you would be able to cover the AEGIR project intro.
Yes, no problem.
Perfect. I'll call you in then. All right. Good morning, everybody, and welcome to AEGIR demo-led workshop series. This morning we will hear directly from the two AEGIR demonstration sites, the Danish demo featuring the original case in Høje-Taastrup as well as BIW demonstrator in Taastrup by the Danish Technological Institute. Then we will hear from the Romanian demo on the single-family building in Oradea, Romania, led by Thermoline, as well as the technical focus presented by our AEGIR partner Westaflex on ventilation approach for Danish and Romanian demo. My name is Bart Rama, and I'm with ICLI Europe, and I'm very pleased to welcome you all to this AEGIR demo-led replication workshop series. But before we get into the content, a few housekeeping points. Maybe next slide. Yeah, thanks. Please note that this session is being recorded. Please keep your microphone muted and your camera off during the presentations. And if you have any questions at any point, please post them in the chat or use the Q&A button. We will address all questions together during the dedicated Q&A session. Thank you. Let's go ahead with our agenda now. I will take a few minutes to introduce the session and then hand it over to our project coordinator to say a few words on the AEGIR project. Then we will have Lise from VTI who will showcase the Danish demo. Following that, Alexandra from Thermoline will present the Romanian demo, single-family home. Then Olaf from Westaflex on the ventilation approach. We will have then the Q&A part, and we close the session with a few key takeaways. Let me start right away with a quick introduction on the AEGIR project, and with that, I would hand it over to our project coordinator, Yulan.
Okay, thank you, Bart. Okay, a few words related to the project. AEGIR project is an European project under the framework program of the Horizon Europe. It's a big project, so we are talking about 29 partners from 9 different countries in Europe, trying to cover the entire value chains of a refurbishing process, going through materials, component system, the digital part, the design of the different components, the construction elements that need to be used, and that finish with 4 demos where we are going to show the developments that we have done in the project. Also, we have some association and dissemination companies that pass in order to produce meetings like this one, and some RTOs as Tecnalia, CSTV, and the others that you can see in the list that are more related to the main developments or the main research that is being done for the different processes. At the end, what we want is we focus on refurbishing, and the idea of the refurbishing is to use modular and industrialized renovation systems in order to improve or to reduce the cost and the time, and also to improve the quality of the final solution. Also, the systems has been designed in order to being able to incorporate or include renewable energy components. Some of them are going to be shown today in the meeting, and also some digital energy management, because the idea is to convert the buildings into nearly zero energy buildings. We have different renovation packages. At the end, the idea is to not have a unique solution, is to have a solution that can be adapted depending on the requirements of the building, the possibilities in relation to the cost, but also depending on the approach that the architects and the users consider the better. Almost the 50% of the project that we have been developed is related to a digital ecosystem that helps the processes from the design to operation, helping the architect, the construction company, and the final user to use better the buildings. We also have some big compromise with circular economy and the Green Deal approach, using materials, recycled materials, bio-based materials in some of the components in order to obtain a better circular approach of the different components. And we have measured the embodied carbon of the different components in order to try to reduce it during the entire process. And all these things has been done in a user-centric way, trying to make it as affordable as possible, to improve the indoor comfort of the buildings that we are refurbishing, and also involving the final user in the solution. And some of the technologies, as commented from the construction point of view, we have this scalable envelope package that are a modular, based on modular components, so like a curtain wall. We have biocomposites profiles for the system, but also in the French demo building we are using timber profiles. Also for the acoustic and the thermal insulation, we are using bio-based materials. You are going to see later the approach that we have to include ventilation in the façade, to remove from the interior of the building and include the pipes in the façade, combining them with some smart windows that helps to improve the indoor air quality. For the energy production of the system, we have flexible photovoltaic and PVT panels. And we have also second life batteries from cars in order to manage and being able to use the energy in different moments of the day. And as commented, the digital solutions that we have, we have a common data environment that manages everything. We have a facade configurator. We are able to obtain the data from the buildings in a faster way with that the typical solutions. With this information, we are able to generate a digital twin in an easier way that we have at this moment. And then for installation and construction, we have developed an augmented reality elements in order to make easier this installation. And during the operation of the building, we have some meta models that helps to take the better decision, taking into account the energy generated by the building and the consumed from the users.
Right. Thanks, Julian, for covering this AEGIR project introduction and for featuring, showing the technologies and other aspects of the AEGIR. Now, I'll move on to saying a few words about the workshop series. As demo-led replication workshop series are designed to bridge the gap between the technical demonstration and market-wide replication. Their goal is to share practical insights from the real-life demos with stakeholders, including architects, engineers, policymakers, and building owners. These workshops are about transferring knowledge from people who have done it to the people who are thinking about it. Maybe next slide. And what these workshops are they building on evidence generated by the demo sites themselves, the technical solutions, the regulatory and the permitting context of each country, and then the construction sequencing. Every demo follows the same common process: assessment, design, procurement, construction, and commissioning. This process in and of itself is a replication framework. They deliver structured replication pathways, what it would actually take to apply this approach in a different building, city, or a country. Maybe next slide. The objectives of the DWS series spell out the ambition clearly. They share practical insights from the real-world demonstration sites. They explore technical feasibility and modular design strategies, discuss strategies to overcome financial and regulatory barriers, adapt solutions for diverse climates and building typologies, and foster transdisciplinary collaboration for scaling up. So now we will continue with the first presenter. Yeah, thanks, Alina. I slowly want to hand it over to our Danish demo, our first presentation, which shifts the focus to the Denmark and the critical challenges of retrofitting social housing at scale. Lise from the Danish Technological Institute will present the journey of the Danish demonstration project. Lise, the floor is yours. Maybe we
Thank
can
you, Bart.
open them. Yep.
Yes. Thank you, Bart, for the nice introduction. As mentioned, my name is Lise van Hortegem. I come from the Danish Technological Institute, and I will talk a bit about the transition from a first planned case study in some social housing residential building to a newly suggested second case study in Denmark. Yes, next slide, please. Good. The original case study is located in Høje-Taastrup, which is close to the Copenhagen area, a bit slightly west of Copenhagen, in Denmark. And the original case study, if you see on the big picture, there's like a red dot from the Google Maps, indicates one building, block 15, that is part of a larger residential social housing area. All buildings, in total 19 blocks in this area, are built during the 1970s. They had some new roofs in around 2000. If we look into block 15, then there's something about how many floors the building has, what the roof area, facade area is, and the total of windows in the building. But what is important is also, if you look at the pictures, how the buildings are constructed. For example, the gables and also the entrance areas, they are consisting of heavy concrete sandwich elements, approximately 70 to 100 millimeters insulation in these elements. And then there's also the other side, the middle picture in the bottom, where we have actually the backside of the buildings with some balconies, and these have a lightweight wooden framed construction. The buildings are heated by means of district heating, and as ventilation, they only have an exhaust-only ventilation system in the building. So the goal to apply the AEGIR renovation to this building was to improve the energy efficiency as much as possible, improve indoor air quality, and also improve the comfort. This building, as you can see, and I talked about it, is part of a larger residential area. At the same time as applying the AEGIR solution, also an overall renovation was ongoing on the other buildings. And I will come back to this more, but this also poses some of these implications for choice of this demo case. Next slide, please. Good. You can see the dot in Denmark, where we're located with the case study. Of course, the case study builds on this AEGIR concept with the industrialized building envelope and envelope mesh. And if you click once more, Alina, then you see in the envelope mesh in the Danish demo cases, we both have an integrated ventilation system. We have some bio-based insulation. We have some facade integrated PV modules, and we use some active windows. We replace the existing windows, and we use some automated opening of the windows. Next slide, please. Of course, when we integrate all these technical parts in the facade, this also poses some requirements to the design. As daylight in Denmark, especially in winter, is quite sparse, we need to optimize for this, as the installation layer in the facade actually results in quite thick facades on the outside of the building. So the design approach for the Danish building has been to like optimize as much as possible, to have as much as daylight as possible entering by angling the area around the windows to the sides of the windows, of course, outward, so we have as much daylight. But also in the bottom, where we have the PV panels on the facade, we angle it outwards to harvest as much of the solar energy. And even though in Denmark we have a cold climate in winter, we also have mild summers, but we still experience to some extent some overheating in the existing buildings. We want to avoid cooling systems. So there we looked into, can we angle the area above the windows so we reduce as much as possible in summer the overheating problems without having to install a cooling system. Next, please. How does this then reflect in like the layout of the facade and the technical build-up? As you can see in the colored pictures to the left, there's different layers in the facade. There's a layer, of course, with the structural frame and the insulation of the facade. On top of that, there's in some parts of the building a layer with cladding. Then there's also a layer, the middle picture, where ventilation ducts are present, which is also seen in some of the configurations in the picture to the right, where we then also add the PV panels. So there's different compositions of the facade. Of course, applying the PV panels also requires a certain distance behind the PV panels for ventilation. So you see the different configurations and also how this then reflects in the design to the right. Also in terms of where to place these ventilation ducts, how to ensure access to the ventilation ducts. And you can see there's an operable mesh panel to access ventilation units if some repairs need to be made, if connections need to be made. Yes. Next slide, please. This is how that then translates to a layout in the building. The picture to the top left shows like the ventilation routing in the facade. And the picture to the bottom shows a detailing of some of the ventilation tubes, these oval tubes that are put in between the existing facade and then a new insulation layer on top of this. There's also like the use of, in terms of PV panels, both angled panels on the facade, but there's also some PV panels on the top of the roof. In total, these panels, they provide a PV energy production of around 84,000 kilowatt per hour, which is and cover up to, I would say, even 50% of the energy consumption in the building from calculations. Yes. So this is then how one of the facades, this is the facade without the balconies. The facade with the balconies had a slightly different design approach to accommodate for the balconies. But this is how the facade looks without the balconies. And you see a quite interesting dynamic between the areas providing PV harvesting and then the shading areas and also areas providing as much as daylight as possible. Yes, thank you. However, in the end, there had been quite some challenges. As I mentioned before, the building is a social housing building. And in these, in terms of the social housing building, there's a building committee consisting of tenants, which in the end were worried about the economy, architecture, and operation of the building. Did any of this operation, uncertainty about long-time operation and maintenance of these new technologies, could this reflect in a future rise in rent? Also, is there any unforeseen costs with this renovation, and does this also reflect an increase in rent? Was some of the worries they had? Also, in terms of integrating, of course, with the other renovation process that was going on in the area. And in the end, also the architecture, of course, the thicker facades, which we tried to optimize during the project, were quite some of the worries the tenants had. If you then click on next time. Yes, and this relates to the general challenges. So in Denmark, social housing, there's some governance that requires tenant democracy. So in the end, a building committee consisting of the tenants, they make the final decisions on renovation concepts to apply to their building. In addition to this, there's a national building fund that usually finances part of these renovation options and also shape the decision around this. As a supplement to this, we also have quite a registered legislation in Denmark with regards to building permits and local plans, especially in terms of these thicker facades that are put on the existing facade. Some of the local plans did not, or the local plan in this case did not allow for dispensation on this. And in addition, we also have the Building Damage Fund in Denmark, which can be used as insurance with these kind of projects, especially related to social housing, and has a quite conservative approach towards the application of novel solutions. So in the end, the technical solution was ready for the Danish demo case. The barriers, however, were not technical, which then leads to the suggestion of a new demo case, which the next slide. Yes, and the next one again. Which is a building called the Building Wood Demonstrator Building, located at the Danish Technological Institute. And the building, as you can see on the picture, consists as a living laboratory. It's a bit smaller than the other building. Has been originally built to document wood construction, but is ideal for test and documentation of innovative envelopes, solutions and materials. And it is quite modular on its own. Next slide, please. Here you can see that we only, with the intervention from the AEGIR project, touch upon half of the building, where we use the AEGIR concept for the facade, which means we actually dismantle the existing cladding of the facade and put the new AEGIR solution on top of this. Next slide, please. In terms of the technical concept, we use the same AEGIR concept, which actually can be easily translated to the new building. The new building is, as mentioned, also modular. We use the same setup, some slight modifications in terms of the angles. In the new demo case, we don't use the angles for the PV panels. We use them as a straight cladding, but still have the angular aspect in order to ensure enough daylight. Also, windows are not changed. We use the existing windows, but have some automated window drives installed. So some small changes, some small adjustments, but an easy translation of the concept towards the new building. Next slide, please. Yes, if we then look to the more technical part, we see the picture from before, the ventilation routing, ventilation pipes. Then you see to the right the new details, with instead of 3 ventilation tubes, now there's 2 ventilation tubes. There's some slight difference in the arrangement of the curtain wall profiles. And then, of course, there's a difference in terms of ventilation routing, since we don't use the existing windows, where we can couple the ventilation to. We now have the ventilation in the facade and then connect it through holes in the walls to the inside. And it's especially these connections, but also connections between the elements when installing it, that is very interesting to look into. And I think Olaf will talk a bit more about this later on. Yes, that was it from my side. Thank you.
Thank you so much, Lise. A really amazing presentation. Next, we turn our attention to the specific challenges and unique solutions for the single-family home in continental climates. So Alexandra from Thermoline will lead us through the deep renovation of the Romanian demo site in Oradea. Alexandra, the floor is yours.
Good morning and hello to everybody. My name is Alexandra Ban and I represent Thermoline company. Today I will present the Romanian demo site within the AEGIR project with focus on the deep renovation of a single family house located in Oradea, Romania, which is in the west of the Romania country. Please, next slide. As you can see, I wrote a few things about the house. It is about building a typical residential construction from mid-20th century, characterized by low energy performance, insufficient isolation, and an outdated system. As Bart already mentioned, it is located in a continental climate with cold winters, but also hot summers, which means that the building needs both heating and cooling, and the demands are significant for a single family home that is around 300 square meters. Next slide, please. The main objective of the intervention within the AEGIR project is to transform this building into a nearly zero energy building. To achieve this goal, we focus on several key things. First, we focus on reducing the heating and cooling demand, then improving the indoor comfort. Also, we try to integrate the renewable energy solution and to ensure that the renovation approach is scalable and replicable. The overall strategy is based on modular prefabricated system combined with beam-based design, the industrialized construction methods. Next slide, please. Now you can see the design of the building before and after. As you can see in the left pictures, before renovation, the building has very poor thermal performance. There were significant thermal bridges, no mechanical ventilation system, and an overall high energy consumption. However, the projects also faced several real challenges. First of all, you can see this irregular geometry of the façade, the existing balconies, and also structural constraints. We also faced limited access for installation, and for sure we need to comply with the national regulation. At the end, the final solution integrates all these aspects into a coherent design and combining a modular façade system with new windows, ventilation, and a renewable energy system. So, as I said, it's not an ideal case. It is a realistic renovation adapt to existing condition of an old building. Next slide, please. Here you can see the beam model of the house. Next slide, please. Okay, and I will speak a little bit about the main thing about this renovation with the façade. The façade are the core of the intervention, and there are prefabricated ventilated façade system. The system consists of fiber cement cladding panels mounted on an aluminum substructure with integrated isolation and ventilation. I put here some photo with some details, but Olaf, I think, will speak in deep a little bit after my presentation. Okay, here there are are colored the AEGIR panels. As I saw at the beginning, we have some constraints about the geometry of the house, and we are not able to put these AEGIR panels all over the facade. You can see the points when we can we try to integrate these AEGIR panels as much as the building permit us. Next slide, please. From a performance perspective, the system achieves a very low U value, around 1.11 watts per square meter. That is a significantly improvement on the building envelope. Next slide, please. Another important thing, it's about the renewable energy solution. As I mentioned early, to improve the envelope, the project integrates a complete renewable energy strategy. This includes, first of all, geothermal energy through a ground source heat pump, photovoltaic panels, and hybrid PVT, but also battery storage. The key idea is not just to add renewable energy technology, but we have to think to integrate them into the building design. This allows us to optimize the self-consumption and generate a significant reduction in fossil fuel dependence, as well as a lower operational energy demand. Next slide, please. Even if it's a single family building, it has significant heating and cooling demand. The main system for heating and cooling, it's a 30 kilowatts geothermal heat pumps. It is connected to an open lung borehole with an approximately 100 meter deep that use a stable ground temperature around 14 degrees. The system provides heating and cooling through radiant ceiling panels. As we estimated, the system will have a highly efficiency with a coefficient of performance above 5 and cooling performance above 6. In addition, the building will be equipped with mechanical ventilation with heat recovery, which is integrated into the façade system. These are the main things about the Romanian demo project. Currently, the project has completed the BIM design and the technical documentation. The prefabrication of the components, it's almost done, and we are in the phase of the construction. Most important, the solution has strong replication potential and it can be adapted to different building types and climates around Europe. So this is not only about one demo, it's about demonstrating a scalable approach for deep renovation. Thank you for your attention and we wait the questions. Thank you.
Thank you so much, Alexandra. It's great to see this developing so well. Now, to deepen our understanding of the specialized components that sort of enable these deep renovations, we move to slightly technical focus on air management. And Olaf from Vestaflex Werk will present the Vestaflex ventilation approach, specifically detailing its application on the Danish and Romanian demo sites. Olaf, happy to hand it over to you. Thanks again for doing that presentation.
Yes, thank you, Bart. My name is Olaf Knospe. I'm working for Vestaflex as a head of research and development. What we are talking about are two renovating, or we have to renovate two buildings here, the Danish and the Romanian building. And in terms of building services, especially ventilation, we have a couple of challenges here, especially the routing of the ventilation system, of the ductwork, and the coordination. That's the two challenges we have to focus on. And we will see two different approaches here. One approach is that we put our system into a prefabricated facade, and the other approach is putting the ductwork on the existing facade. So the Danish demo we will start. Please change the slide. Yeah, the first approach. Yeah, putting the existing or putting the ductwork system in the prefabricated facade. You see here. What can you see? You see the building and the distribution of the system, which is rather a real network because of the approach we have done here, that we have to ventilate two different levels, yeah, of the building, and even so we have to differentiate between different rooms. So therefore we get quite a network over there. Please change the slide. No? Yeah, the next slide you see the vertical part, or on the left hand side you see the vertical part of the building as a sketch, yeah, and you see the supply as example, and the routing where we route the ducts, yeah, to every window, so that we can ventilate this system here through the window, or instead through a special outlet we have to design here to get the air volume flow into the building. We on the right hand side, you can see the ventilation ducts, yeah, within the prefabricated facade. The next slide, please. So now we'll come to the very tricky part, which has a lot of coordination involved. What you can see here is the ductwork system, which is connecting the room, yeah, and the roof, and is partly a part of the prefabricated facade. Yeah, especially on the right hand side, the section on the right hand side marked BB, yeah, you will see the very tricky assembly, yeah, of the prefabricated facade, because you have to assemble the horizontal ducts and the vertical ducts during assembling the prefabricated facade. So you have to be very precise, yeah, putting the duct work into the prefabricated facade, and then when you assemble it, you have to connect the horizontal part to the vertical part within the existing or within the prefabricated facade element. We have developed a new component, yeah, for assembling both the vertical and the horizontal part, and that will give us the opportunity drilling the hole before drilling a hole through the wall before we can assemble the prefabricated facade element, yeah, and then putting the duct, the horizontal duct, yeah, and connecting the horizontal duct to the vertical duct. That's we have to test that. The test will come up in the near future. So, but we are very happy then when it works, and we're confident that it will work. That's the main challenge here on the ventilation side for the Danish demo. Now we can change the slide. Okay, that's the Romanian demo, and the family house is somehow different. Now we can change this slide, please. So what you can see here is that on the left-hand side, we see the routing outside the building, yeah, on the existing facade. So the routing designing the routing is here somehow different. We have to find ways for our ductworks, yeah, or for our ductwork system, that we can connect the air handling unit or the ventilation unit, yeah, with our ductwork system, and connecting the ventilation unit to all ventilated rooms, which is not that easy because we can't drill holes, yeah, inside the building. So we have to get out with our ductwork system, yeah, and distributing that around the existing facade. And the routing is shown on the right-hand side, so that you can see that you can see the ventilation units as rectangular parts, and then the distribution, so that we go partly with our ducts through the rooms within the roof, yeah, and then going outside with our ducts and distributing the ducts on the existing facade, and the new facade will then be on top of the existing facade. So we get a real thermal insulation for the ventilation parts, which is important. Otherwise, we have condensation, and we have to avoid condensation within our ducts. So these are the main approaches, yeah, we have designed, yeah, and the different two approaches. So that's from my side, from the building services.
Thank you, Olaf. Thanks to Julen, Lise, and Alexander. Now we move to the Q&A part. So please use the chat to post any of your questions. We will read them, or we will allow the speakers to read them. Feel free to post them right now. If not, I can probably break the ice with the few questions. Maybe I'll start with you, Lise, on the Danish demo. We've seen the kind of the transition from the old site into the new site, and the way we had to adjust the solution. So how easy it was to kind of translate the concept, AEGIR concept, from the old site into the new site, and what were the challenges or what we needed to adapt to make it fit, or maybe we didn't need to adapt anything. Thanks.
Yeah, thank you, Bart. I think in terms of like the way the package functions, it was quite an easy transition as the both buildings were modular. But there were some issues related to materiality, of course, but also in terms of the existing facade on the new demo building. How much do we need to remove from this facade? Can we reuse the windows, or do we actually implement new windows? We decided to keep the existing windows, which then posed another challenge, because the routing of the ventilation needed to be done differently, and also the connections needed to be done differently. And I think that's one of the main issues, like a new concept needed to be developed for the connection of these ventilation pipes, but also like the entering through the walls in the building. And I think that's from my side what I see as quite a technical challenge. Also, Olaf commented on this. Yeah.
Great, thanks. Now to you, Alexandra, on the Romanian demo. You mentioned some constraints, some actually on-site constraints, like irregular geometry and limited access. What did you do to overcome those challenges, and how do you think the solutions came about to be?
Thank you for the question. It was not easy at all. At the beginning, we have some ideas, but after we begin with the design and we go deeper, we realize that there will be some changes. And this was one part. The other part was to communicate with the owner that seems to be a little bit unhappy for some aspects. But at the end, we managed this, and I think that in the end, we have done a good job all together with the AEGIR partners. And also the owner is happy with the final solution. But it was not easy to integrate all these aspects in. There was a technical constraint. That's what we need to do. What we have done in the grant agreement, and we have to do by AEGIR project. There was the owner that has some ideas, and at the end we fit all, and I think that we have done a good job.
Great, thanks a lot, Alexandra. Of course, yeah, amazing job. Olaf, on the integration of the ventilation systems directly into the prefabricated facade panels, what do we see as a technical benefit? Of course, there are so many challenges. I remember with discussions we had at the early stage of the project. Of course, you then had to install the new piping, and you install the central system within the building. So I think the solution was to kind of decentralize or sort of make or less disturbing for the inhabitants or for the residents. But yeah, please.
Yes, actually, that's the main advantage. Yeah, when placing the ductwork system outside the existing building. Yeah? So you do not disturb, or the disturbance is very low. Yeah, the occupants, and then you can assemble the facade elements outside the building, and it's much easier than for assembling. Otherwise, you disturb the occupants a lot, and you need just a few holes in the facade, in the existing facade, and that drilling holes is very easy. Yeah, removing some parts of the existing building is much more difficult, and that's actually the main advantage here.
Great, thank you, Olaf. Alexandra, back to you on the geothermal energy. You mentioned the ground temperature, the performance of the geothermal. Can you explain a little bit more? Of course, we all know, I mean, drill, you install the piping and everything, but maybe you can just shed some light on this, how the approach was, and what you think the replication issues or challenges would be for the others. Because I know your background is on technical, mechanical.
Yes, we have background on this file. The idea was that first the building has an electric system for heating, cooling was no earlier, and the consumption was huge. Also, with the increasing price of electricity, and the owner was very unhappy with this system. We propose this geothermal system for the owner, but the idea is that we faced some challenges in these aspects, because normally the end user think that if they install a geothermal system, all will be nice and the consumption will go down and the bill will be significantly low. But the reality is that the geothermal heat pump is not the solution without a correct envelope of isolation of the house. And this is the message that we want to transmit and to underline, that the heat pump and the geothermal heat pump system, it's not enough if you want a better less energy bills, because the heat pump without the correct envelope of the house is it's not a solution. It will even increase the invoice that come, and the owner was very happy with this approach. Of course, it benefit of this project, and he has not to pay this deep retrofitting. But we think that with this approach, and in the next period, we will also monitor the house and we will have exact data. And I think that this will be very important for the scalability and for the replication of this demo site.
Right.
I hope I answer your question.
Absolutely. Yeah, absolutely. That was very detailed, actually. Lise, on the Danish demo, and again, we're hearing a lot on the technical solutions, but in specific Danish demo, we had some additional barriers on the not getting along, but getting the stakeholders on board. Initially, they agreed, and then it was this, as you just mentioned on the slide. So what do you think are the most significant non-technical barriers encountering all the replication? I'm not talking specifically on the Danish demo, but in general, having this experience, having gone through this experience, what do you think for others should take into consideration? Again, it's step-by-step, incremental steps, we all know, but yeah.
Oh, it's a very good question, Bart. Also not one easy to reply to. I think it depends on like what the different countries have as a housing concepts. I think for us in Denmark, the first building was a social housing residential building, which put some more constraints around how it is operated and how rent is fixated. And I think that was one of the main issues here. There was a lot of uncertainties on the economy, also the Danish building traditions and legislations around it. So I think especially this last part could be maybe on some other buildings in other countries also be a deal breaker or not. Depends a bit. I think in terms of the new building, we of course again have like the building regulations putting a thicker facade. Depending on the thickness, there could be some constraints. There is fire classifications, there's construction documentation. So we have a whole very heavy documentation process, at least in Denmark. But I think there's a potential for a lot of buildings. I mean, especially if we look into the first case in Denmark, there's a lot of these kind of types of buildings built in the 70s that have this same modular approach, same construction approach with concrete sandwich elements. So I think if we take away the constraints from the social housing and open up a bit more about the legislation, then I think there's a huge potential for use of this solution. I hope that kind of
Sure, yeah, absolutely.
Answers the question.
Yeah, absolutely. And Yulen, I just written on the chat, I want to invite you, having had this project coordinator kind of helicopter view on all the sites, I would like you to say maybe in 30 seconds or a minute, just like the whole 4 sites. What do you think it's? I don't want to restrict the challenges and solutions, but just maybe a few words on from your perspective.
At the end, has been a huge work the one that has been done in order to reach this point. Usually in this type of projects, we have problems, as Lies has commented about. Okay, there is some problems with the demo. We need to change. The good thing is that we have in the consortium the possibility to do it. And now we are in the phase of manufacturing and installing the different components. And probably we are going to face different problems. The idea at the end is to reach the objectives that we have when we submitted this proposal. Seems that we are going to be aligned with these objectives. And then we are going to have this last year of the project in order to check where we are in reality, not under simulations, from the different approaches that we have in the demos that you can see that are quite different one from the other. So, okay, let's see, probably during the next year, we will have another webinar in order to show you the final pictures and the final installation in the buildings and the first results of what do we reach from the initial objectives that we have for each of these buildings.
Amazing. Thank you. Thank you so much, Yulen. And I think next slide, we have the key takeaways. Alina? Yeah. Yeah. I think Yulen has already covered, but let's maybe sum up. I would say the demonstration projects confirm that while technical solutions for deep renovation are mature, their successful deployment relies on navigating complex social and structural landscapes. In this case, in Danish context, the transition to the built-in wood testing facility underscored that the governance and financing rather than technology remain the primary or first barriers. So achieving replication requires early alignment with stakeholder decision structures as well as the social housing regulations. In the Romanian demonstration, further, it's proven that the scalable renovation is feasible at the single family level when solutions adapt to the real world building constraints rather than the ideal cases. Again, as Alexandra just explained, utilizing an integrated system of facade, ventilation, and renewables. And of course, central to all this success is the ventilation approach, which demonstrates that embedding air management directly into facade systems, as Olaf has explained it in detail, is critical for balancing energy performance as well as the occupant comfort, rapid space efficient, as well as the scalable deployment across diverse building typologies. Maybe we move to the next slide. On the next steps, as Julian has mentioned, we are planning another series of demo-led replication workshop, but that's, as we announced previously, will be held once all the renovation work is done, and we will cover all the demonstration sites. I think, again, around September timeframe, but we will announce the exact dates, so stay tuned. And of course, stay connected with us. Again, if you want to have, meanwhile, we will organize some site visits. If you're interested to participate in one of the site visits, please contact us or directly our demo representatives, and we will happy to facilitate that. And I guess with that, I thank everybody for participating, and